Okay. Settle down. Settle down. I know it's a little crazy. We're just coming back from vacation here, but we got to get focused because we do have a lesson for today. Before we do that, I want you guys to let me know via email if the quality of this is good, like are the audio levels right? Because that's something that I can't really test myself. So just let me know in an email if it doesn't sound good, and I'll try to fix it as best as I can. You guys can go to Google Classroom for all the assignments. As you can see on the board right here, I've got Google Classroom up. So this is what it's going to look like here in your stream. And you can see today's or yesterday's post is here as well. But if you go to the classwork tab, I feel like a lot of you don't know about the classwork tab. You can see the breakdown of all of our assignments, and everything we do from home is going to be in the learning from home section. So everything you have to worry about for this will be there. All right. Next, let's get into today's lesson. So first off, you guys need to take notes with this. We're changing kind of the content we were going to do now that we're home. We're going to do some different topics than I was previously planning. So what we're going to do today is talk a little bit about charge. So if you remember in class, charge we found was mostly just electrons moving around. And we started to define charge as an object has too many excess electrons, meaning it was negatively charged because it had those extra electrons, or it was lacking electrons. It didn't have enough electrons on it, which meant it was positively charged. So the problem with this is we're dealing with a tremendous number of electrons in real life. Real life objects have millions upon millions upon millions of electrons. So just to give you an idea, a possible charge of our Van de Graaff generator, which was negative, would have had about this many electrons on it. So I'm just going to go ahead and start writing this number here. You guys ready? Here we go. Yeah, that's about right. That's about the number of electrons just on the Van de Graaff generator after it charges up for just a little bit. So it's an enormous number, right? And the problem here was all of this stuff was being discovered back in the day. One of the main scientists behind it was a guy named Charles Coulomb. And he's had some stuff named after him, like Coulomb's law, because he was really trying to figure out how to quantify this repulsion and attraction that we saw. So like when we were playing with the tape way back in the 1700s, he was like, how do we quantify this? So he sat there and he was like, I will find the smallest charge that I can. And when he did, he determined and called that 1 Coulomb. So he said, all of this charge that I can detect, so say all of the amount here in this box that I have right up here, all of the electrons in this box are going to be equivalent to what he called 1 Coulomb. And that amount now we know today is that crazy long number I just read out, which is, to write it a little shorter, 6.25 times 10 to the 25th elementary charges or electrons. So this is going to be our conversion factor, if you will. So what is defined in our SI units or our standard units as 1 Coulomb is just 6.25 times 10 to the 25th elementary charges, or 6.25 times 10 to the 25th electrons. So some of the work that we're going to do in this unit as we kind of move forward, we're going to be using this number because it's electrons. That's what makes sense to us when talking about charge. And we're going to be using this number because that's how we're going to have the charge on real life objects. So let's look at this quick example. An object has a charge of -6 coulombs. How many excess electrons are on the object? So the first thing we need to do is figure out how many elementary charges is equivalent to -6 coulombs. So first, make sure you have your scientific calculator with good old-fashioned exponents on it ready to go. And let's do this first with dimensional analysis, like we did in the beginning of the year. So let's kind of set it up like this. Let's say, all right, we've got -6 coulombs. And whenever we did a problem in dimensional analysis, what we did was we put it over 1 to start, and we multiplied by a blank fraction. Now, what unit do we want to get rid of here? We want to get rid of coulombs, and we want to end up with elementary charges. So we set it up like this. So this way, when we do it, coulombs will end up canceling out. And now we can go in and fill in the corresponding numbers according to this conversion factor that we have here. We know 6.25 times 10 to the 25th elementary charges is equivalent to 1 coulomb. So what's the math I end up doing here? Well, as you guys know, I'm going to end up multiplying across the numerator and denominator. Since the denominator is 1, I'm just multiplying these two numbers. So what we'll do is we'll come to our calculator. I'm going to turn mine on real quick. And we're going to give it a shot. So we're going to do -6 times, and then we're going to go 6.25. And I'm going to use the E button here. So I'm going to hit second and then comma, which is that EE. Times 10 to the 25th. And that does all of the exponent work for me. So I'm going to hit enter, and I've got my answer. So I've got -3.75 times 10 to the 26th. So I end up with this many elementary charges. So what does the negative sign indicate to us here? This negative sign is just indicating that it is a negative charge. So how many extra electrons do we have? This means we have 3.75 times 10 to the 26th extra or excess electrons. And that is our answer there. So hopefully that was a pretty easy and straightforward conversion. If we got a positive number, we would know that we were missing that many electrons. Let's go on to this next question. If an object is missing 2,000 electrons, what is its charge in coulombs? So let's give this one a shot. So if the object is missing 2,000 electrons, we're going to say the object has a charge of positive 2,000 E, or positive 2,000 elementary charges. Since we're converting, we're going to set up our blank fraction, as we always do, and then we're going to put our units in so they cancel. So elementary charges will go on the bottom, and coulombs will go on top. Because in this problem, we want to end up with those coulombs. So now we can plug in our numbers. 6.25 times 10 to the 25th elementary charges is equivalent to 1 coulomb. So let's do the math here. So I'm going to start off here with 2,000 elementary charges divided by, and remember, if you're not using the E button, be very careful. Make sure you put your denominator in parentheses. Otherwise, order of operations might mess up on your calculator, might end up with the wrong answer, even if you did all of the actual physics right. So 6.25 times 10 to the 25th. So I'm going to close that, and here we go. So now we have our answer. Our answer is 3.2 times 10 to the negative 23rd coulombs. So that would be the charge of that object if it was only missing 2,000 electrons. So obviously this is going to be a little weird to you guys. These are some uncomfortably big and uncomfortably small numbers. But the thing to kind of take out of this is this one quick rule. If you're converting here, as we did here, from coulombs to elementary charges, you can simply multiply by 6.25 times 10 to the 25th elementary charges. If you are going from elementary charges to coulombs, you can simply divide by 6.25 times 10 to the 25th elementary charges. So this way, it's just a quick thing to remember, and you guys will have your notes with you when you do all the assessments and Castle Learnings at home here. So this is a quick way to go back and forth between the units based on what you need to answer the questions. So let's look at this interesting question right here. Could an object have a charge of 1.368 times 10 to the negative 24th coulombs? So I know that's annoying over there with the units down there, so I'll just redraw it and bring it up here. So could it have this charge? And that's kind of a weird question, right? Like, could an object have that charge? Sure, why not? Tell it has that charge. But the weird thing is, when talking about objects, and yeah, I'm gonna bring up something real quick. Just give me 1 second. So, sorry. Oh gosh. So let's go to here, the old atom builder. Everyone loves it, right? So let's say we made a nice lithium atom here, good old-fashioned lithium, and it's a neutral atom. So as we know, a neutral atom of lithium is going to have 3 electrons, 3 protons. And what is its charge? So let's pull on this charge thing. So we see neutral. So if I add an electron, I end up with a charge of -1e. And another electron, -2e. If I take electrons away, right, back to neutral. Now we're back to +1e, +2e. Have you guys noticed that every time we've done this, and all of the examples we did in class before we were off, did you notice that all of the objects always had a charge in elementary charges that was an integer? You never had a charge of -2.5e. And that's because you can't split an electron. It's one of the fundamental building blocks of everything. So it's the smallest thing we have, and we can't break it down any further. So that means that our charges have to be in integers. So this type of question is actually an interesting question to ask of any charge that's given to you. Is that a charge that an object could have? So how would we do this? Giving you time to think like we would in class. It's a little weird. I guess you could just pause the video. Yeah, I'll just tell you to pause it next time. Right. So all we've got to do is convert this to elementary charges. If we get an integer number, we know that yes, this is a possible charge an object can have. But if we get any decimal points, then we know it's not the possible charge an object could have. So let's try this one out. I have a charge here in coulombs. So as we remember, if I want to go from coulombs to elementary charges, I can multiply by 6.25 times 10 to the 25th elementary charges. So here we go. So I've got 1.368 times 10 to the -24th coulombs. And I'm going to do the full dimensional analysis here just to kind of go through it and give you guys a little more exposure to it. But again, like we said, we're multiplying by 6.25 times 10 to the 25th elementary charges. So let's do it. Back to our calculator, we'll turn it back on. So we got 1.368 times 10 to the -24th times 6.25 times 10 to the 25th. And what do we end up with? 85.5e. Is that possible? No, not possible. And that's it. So you guys are going to have a Castle Learning posted. You'll see it's posted with this right now. That Castle Learning is going to have some questions a lot like these. So hopefully it shouldn't take you too long. It's going to be graded as a homework. So it will be graded out of 3. Same rules in class apply. If you guys get an 85 or above on the Castle Learning, then you guys get a full 3 out of 3 as your homework grade. All right, I will see you guys tomorrow. Hey, oh, there we are. Oh gosh, were we on the wrong screen the whole time? No, we weren't, right? I don't know. This thing is gonna be annoying. Oh, there's the bell. See you later.